Hey everybody, this is Alex Merced, developer advocate here at Dremio. And what I'm going to do is just walk through a tutorial blog that I published back on July 28th, showing you how to basically ingest data using Flink into an Apache Iceberg table. Okay, we'll show you an example formula, a very simple example, just to kind of really illustrate the process of doing so. So I figured let's actually do it together. Okay, so what I have here is just a blank folder in VS Code. And then here I have my blog. Okay, so essentially, if you want to do this, you need to have Flink. Now you could install Flink. You can go use third-party services that sort of provide Flink, like going to AWS and spinning up something like a AWS Firehose that allows you to use Flink, or Decodable, which does things through Flink, and so forth and so forth. But the idea here is to show you how to kind of do it in a very raw way, so that way you can then take those learnings wherever you decide to use Flink. So we're going to use Docker to create our Flink image. Now the thing is that Flink needs any jars that it's going to refer to sort of in its class path. So if you're not familiar with Java, the idea is generally all the different other code that a Java application may refer to has to be within its class path. So it's basically a folder where all these compiled Java classes that it expects to have available should be available. Okay, so in that case, we need to kind of customize the standard Docker Flink image in order to, well, for it to have these specific jars, those compiled Java bits of code, available. Okay, so essentially what we can do is we can create a Docker file. Okay, and we're not going to necessarily compile this because I've compiled it already. But basically what would happen is you would create a Docker file, which would look like that. And it would have this code. Okay, and here's this is an example. And again, you can modify this based on the blog. But essentially what I'm doing is I'm taking the original Flink 1.16 image from Docker Hub. So that's what this from means. And essentially what I'm doing is I'm just making calls to download the jars that I depend on. So basically this is saying curl is just a way to be able to request data. So I'm requesting from the URL where that jar is located to download the jar. And I'm saying take that output. So download that and output it to here. So it's going to output it to this folder in the Flink class path. So in the Flink container, this is the class path. So this folder is where any jars should be. So you'll see like each of these are just me downloading that particular jar to that particular folder. Okay, and essentially things that I need is like the Iceberg Flink runtime. That's going to have all the code that you need for using Apache Iceberg with Flink, so that way we can save our data in an Apache Iceberg table format. So that way you get all the benefits of Apache Iceberg, such as time travel, ACID transactions, directly on our data lake. Okay, the Flink SQL connector for Hive, that's just so that way we can use Flink SQL in certain places. Hadoop, generally just require these Hadoop are just dependencies just for Flink to kind of just work in general. And then this is the AWS bundle if we're working with S3, which we are, not technically with AWS S3, but with an S3 compatible storage layer in the form of Minio. Okay, so essentially I'm just adding those paths. I'm installing Nano, which is a text editor. Not going to be needed, so technically you don't necessarily need that line, but it's there. And then this is the command to start the Flink cluster. Okay, and that I just borrowed from by referring to the original Docker file that was used to create this image right here. How did I find that? Googling. Okay, so that's essentially what I could do is I could then compile or build this Docker image using this command docker build, and then just give it a name, and then I'd have that image. I've already done this and made this image available to you. Okay, so that image name is Alex Merced Flink Iceberg 1.31. So you don't need to do this to follow this tutorial. But again, in the future, you may need to add jars to the Flink image for other use cases, to use other tools. So in that case, I just wanted to kind of go through that so that way you know how to do that. So what we want to do is set up an environment with this Flink image and a bunch of the other types of things that we need running to create the environment we need for this tutorial. Okay, so for that, we have Docker Compose. Okay, and Docker Compose depends on a file called dockercompose.yaml. Okay, that's the specific file name it expects. Okay, and here's the Docker Compose YAML that I already have set up for this tutorial. We'll walk through it just so that way you know what it does. Okay, but essentially, we have several different services. So a Docker file, a Docker compose file is basically saying, hey, there's all these services I want running, each of them being an individual container that I spin up from a particular Docker image. So we have our Spark Iceberg service, which is made from my Spark 3.4 notebook. It's basically what it is. It's a container running Spark 3.4 along with Jupyter Notebook. We're not going to really use it for the tutorial, but the idea is that it's there if you did want to go kind of do some work in Spark afterwards. Okay, here we're going to have the Nessie catalog. So we were going to call that service catalog. So we named the service catalog. Okay, and that is named Project Nessie. It's Project Nessie is a catalog that allows us to track our Apache Iceberg tables. So the nice thing about that is like I can use Flink to ingest the data into these Apache Iceberg tables, but then I can bring those tables to Dremio, to Spark, to any tool that supports Apache Iceberg. Okay, so that's a nice thing about being able to use Nessie. Lots of tools support Nessie. I mean, you have like Presto, Trino, Flink, Spark, Dremio, and many more supporting Nessie. So that way you can just bring your Apache Iceberg tables nice and neat between these tools, on top of having all the Git-like features where you can branch and merge and create sort of zero clone copies all straight of your catalog with, pretty easily. Okay, but essentially what we're saying in each of these is we're just connecting it to this particular network. So again, we're creating a network that they're all going to share. Okay, and that network is defined here at the bottom of the Flink container, or of the Docker Compose file. Okay, but again, we have the Nessie catalog, so that's what this creates, which by default has no authentication. Again, you can customize any installation of Nessie to have different types of authentication systems, use different types of backend databases to track the data, but by default, it's going to use memory for its storage and have no authentication, which is going to be perfect for our purposes. Then we have Minio, which is going to be basically our S3 compatible storage layer. Okay, and essentially we're using a specific version of Minio just so that way everything kind of stays consistent, and you do this tutorial 10 years from now, it should work exactly like it did today. Okay, now in Minio you can configure a lot of things. Like a lot of containers, you're allowed to specify environmental variables that'll basically affect how it gets created. So we can sit there and say, hey, I want the username and password for this Minio instance to be this, admin and password. Okay, these are just like specify a region, some other things, not particularly important for our purposes today. And then again, we're exposing the ports for each of these containers, saying, hey, which ports are they going to attach to our local system so that we can access all of them. Okay, also we're going to have this Minio client. The purpose of this Minio client is really just going to be to initially create some of our starting clusters, our starting buckets. So if you see here, essentially what happens is that when this bucket starts out, that's what this entry point piece is. It's just saying, hey, run these commands when this container starts. It's just going to run a couple commands to create a couple buckets, make them public, and so forth, which you can see here and you can customize to your needs. Okay, and then we're going to create two different Flink containers. One's called the job manager. The job manager is sort of like, think of it like, imagine like there's a field of workers. Okay, there's someone who's supervising them and telling them what they need to do. That's the job manager. Okay, then there's the task manager who goes out and is actually those individual workers doing the things. Okay, so the job manager manages the job, which is made up of several tasks. And then each task is given to a task manager who then manages handling that individual task. So basically we're going to have one job manager and one task manager. Okay, and basically what we do is instead of using the entry point command that's already built into the Docker image, which is this, okay, we specify an alternative command and we say, okay, hey, run this command instead. Okay, so job manager for that, task manager for that. And then again, specify any environmental variables that particular thing needs, okay, which you can see in there. Okay, so that's essentially what this particular deal is doing, this Docker Compose file. So basically, once we have that all set up, we're going to eventually be able to spin it up, okay? So what I'm going to do, though, is instead of spinning them all up one time, I could just spin them all up by doing Docker Compose up. Okay, so I could just be like Docker Compose up and be like, yay, that's good. What we're going to do is first, before we spin everything up, we'll spin them up each in their own terminal. And what we're going to do first is actually set up our Java job. Okay, so another thing you'll need to have installed, you'll need to have Java installed, Java 8 or Java 11, ideally. And you'll need to have Maven installed. Okay, because Maven will be the package manager we'll use to start up a new Java project. Okay, so if you've ever done any programming like JavaScript, you have like Node with NPM. If you've done Python, you probably use pip. Think of Maven as kind of like in that same sort of category of helping you manage a project. Okay, so what I'm going to do is I'm going to create a couple folders called warehouse, but that's not the create a folder, warehouse and notebooks. Now the reason I'm creating these folders is because I'm mapping them here in the Spark Iceberg. I'm mapping them to the container. So that technically, like if I want to have any pre-made notebooks, I could just put them in these, or pre-made data that I want to have access to, I could put them in these folders, and they'll be accessible in that and from that Spark container for any like PySpark jobs. Again, not something we're going to do in this tutorial, but again, you could do that with any of these containers. And so you could do that. Okay. So now to create our Flink job, what we're going to want to do is once you have Maven installed, and if you want to be sure that you have Maven installed, you can just do Maven -- version. Okay, and that should eventually come up with a version number. So I can see I have Apache Maven 3.63 installed. Okay, then what you're going to do is do Maven archetype generate. So basically what we're doing is we're just generating a new Maven project. Okay. So it's going to ask me a whole bunch of questions, because the thing is that Maven has all of these sort of pre-made projects that I could be generating. So I could give it a number and it'll generate like one of these like basic pre-made archetypes for different situations. I'm going to leave the default because I just want a blank project. So I'm just going to hit enter. Okay, now it's asking me sort of what version of basically what version I want to use. So I'm just going to kind of keep it at the default. We'll change that again later. Okay, we're going to define a value for property. So essentially what happens is that when you name a Java package, okay, generally what you're going to do is we have different parts. So you have the artifact ID, okay, which is not what we're doing here. We have the group ID. Group ID is usually identifying like who's building the package. Okay, so like if we were working for a company, you know, dogsandcheese.com, okay, so then you would call the package com.dogsandcheese, because that way you have sort of a unique thing identifying who is building this project. Okay, and it's in that reverse domain notation, usually the group ID. Okay, I'm just going to put com.myflinkjob as I put in the blog post. Okay. And then there's the artifact ID. That's usually the name of the specific thing you're building. So in this case, we're just going to call it Flink Job. Okay. And it's going to ask you for a version number. That's fine. Pretty much everything else, you can kind of just accept the defaults. I'm going to hit yes for yes, that all looks good to me. And then it's going to build out all these folders. So you can see here, it creates a folder for this project, Flink Job. Okay. And then the source code is in this folder called source. And then the basically two folders. There's like the actual code for the project, and then the test code if you want to write test code. I'm going to basically just zap that folder because I'm not going to write any tests for this particular exercise. And basically it says, okay, here's the Java code. And then again, it's just going to follow that name we just outlined. So, right, we had so if we follow this, basically, isn't that our group ID, com.myflinkjob? Okay. And it's part of so basically that becomes the package name. Okay. Cool. And then you basically have your basic class, which is app.java, which is essentially the idea app for your application. Okay, so essentially that's the setup we have here. And then we're going to have this pom.xml file, which if you ever worked, again, with JavaScript, think of package.json, or if you're working with like pip and Python, requirements.py, or if you're talking about Rust, the cargo.toml, it's that file that defines what dependencies, like what external code you're using in there. It defines a lot of other settings for the Java compiler. So if one of those things we want to change is like actually right here. So you see here, this setting right here is telling what compiler, what version of Java to target. We want to target Java 8. So that means changing this to 1.8. Okay, so we got that out of the way. Cool. And now what's going to happen is, as you see, there's this dependencies section. And each dependency is basically a little setup like this. Now, if I was looking up different dependencies, I could go to the Maven repository, and I can go look up different, things. So for example, we're talking about this Apache Hadoop common. If I wanted to add that to my dependencies, I would just go down here. Depending on which tool you're using, I'm using Maven, but you could also be using Gradle, SBT, IV, grape, it'll show you how to add it to that particular tool's dependency list. So since we're using Maven, okay, there's the XML for that particular dependency. I could then copy that over to my pom.xml. So that way when I compile the jar, it knows what my dependencies are. So I tried to make this easy for you. So I already gave you the list of dependencies. So we can just literally copy these dependencies over. Okay, let me just make sure I got the whole thing. Start from here. Okay, and we'll just plop that right into our pom.xml. Okay, awesome. Okay, and then, you know, VS Code, because I got all the Java extensions all nice and ready for me, it's going to be like, hey, you updated your pom.xml. Do you want me to kind of sync everything together? And I'm going to say yes. So that means it's going to know, so that way when it's like linting my code or like kind of doing its grammar check, it's not going to be telling me, hey, you don't have these libraries installed. It knows because it's just synced with my pom.xml, which said, hey, these libraries are being used for this project. So cool. Okay, so we already changed the 1.8 there. That's all good. Okay, and again, the reason why that's important is because if you do not do this, it's going to say, hey, I can't compile to that version. And again, you can't go too high either. So if you do like Java 17, you might get this error. So generally 8 or 11. So that'd be either 1.8 would be for 8, or just literally the number 11 for Java 11. Java 17, you'll get this error right here. Okay. Now, cool. So that's kind of our setup. So we've set it up like basically a blank Java project. And what we want to do is we want to write a Flink job. So a Flink job at the end of the day is just a Java jar. Okay, it's just a jar that we're going to pass to the job manager, and the job manager is going to follow the instructions. But because, you know, that job manager has access to all the Flink libraries, we're able to give it instructions that it understands that are part of the Flink APIs, which come in 2 flavors. There's the data stream API and the table API. So the data stream API allows us to work with data a little bit more imperatively, so more Java-y or Python-y, depending if you're using PyFlink. And then there's the table API, which allows us to interact with the data as tables, which for data that would work as tables, and we can use like SQL and things like that. So you'll see a little bit of both in this. Okay, but what we're going to want to do is, just so you know, the way the job manager works is that there's Flink operators. So these are operations that the Flink job manager will identify as unique pieces of work. So once we drop the job the job in the job manager, it's going to create like a visual saying, okay, hey, this operator's finished, this operator's finished, this operator's finished. So we want to make sure there's an operator. Like basically the code that I've written here doesn't have much in the way of operators. So to make sure that there was an operator to show visually, we're going to do a map. So what we're going to do is we're going to map our data to a custom data structure we're going to create right now. Okay, so that's what this example data class is. It's just going to be a custom data structure for us to map our data to, so that way there's some sort of operator, or else the job manager throws like, it will do the job, but it'll complain that there's no operators. So that is the reason for that. Okay, so how do we do this? We just create a new class. So I'm just gonna go into my package here, my Flink job, and I'm gonna just create a new file. Okay, and we're just gonna call it exactly what we're gonna name the class. So example data.java. Okay, then I can copy over the code. Okay, and let me make sure I get the package in there. And again, if you called your package anything different, make sure that your package name matches whatever you ended up calling yours. Okay, and this always happens every once in a while. I think usually to solve this, I have to close and reopen VS Code. It just gets stuck in the syncing of the pom.xml. So reopening VS Code, just make sure I copy this over here. And again, you might be using IntelliJ or some other IDE. Anything works. So let me go back to the example data file here. Paste this. There we go. And it's a very simple class. Essentially, we're creating a class that represents the data that we're going to be ingesting, which is just data with 2 fields, an ID and a field called data. Okay, nothing fancy here. We're just showing you how they get from point A to point B. Okay, so let me just close all these. But if you're familiar with Java, you got to create your getters and setters. So, okay, so each of these fields have a getter and a setter. So a method that's going to allow you to get the data and set the data. Okay, so once that's all set, okay, we can now head back and copy our main code for the actual Flink job. okay, which is all this, and we'll walk through it so you can see what this code is doing. Okay, so I'm going to head back to app.java. Let's just paste this code in there and we'll walk through it. So here I'm just importing all my dependencies. Mostly it's stuff from the Flink libraries to do specific things that I'm doing in here. So again, data stream, because we need the data stream data structure, because we're creating a data stream with our data. We need our stream execution environment that just essentially creates the environment to use the data stream API. The map function, we're going to use that to map the data stream to our custom data structure, the example data tuple, because we're going to have some tuples that we're going to work with here and there. Again, a tuple is just basically kind of like a list of items, but it's a fixed number of items and a fixed number of items. So this is a tuple of 2 items. Okay, a table, basically that's going to be for us to work with the table API, which we will enable using the stream table environment. Table result, that's just basically a data type for the result of a table operation. Environmental settings is just for setting the settings in your Flink environment. I forget what the $sign does. And then again, we're importing our example data type since we're going to be using it a little bit later on. Okay. So essentially those are that's what I'm bringing in to use in this file. Okay. So here we have our app class. And then again, if you ever use Java, all the stuff that's going to happen is whatever's inside the main method of that class. So essentially we're going to tell, when we send this to the job manager, we're going to say, hey, job manager, I want you to run this specific class, the app class. And then it's going to run the code that's inside the main function. Okay. So first thing we're doing is we're just setting up that stream execution environment. Okay. So again, when Flink is processing, it's for processing streams. So you're creating that environment for that stream so it can process it. Okay. And it's basically, we're going to use this object, this env object is what we're going to use to kind of do all our operations. And it's going to look for operators, and that's going to be what you see on the Flink UI. Okay. So we're going to take that environment that we just created and then pass it to the stream table environment creator, so that way we can create a stream table environment so that we can do table operations. Okay, and that's going to be our table environment. Now with that, we can now interact with our job via SQL, because we're using this table environment that allows us to work with structured data in SQL. Which for many people is going to be much more intuitive than Java. But basically, first thing we do is we create our Iceberg catalog, because again, the way Apache Iceberg works is that you generally interact with a catalog, and the catalog tracks basically the current state of the table. So every time I do an operation on an Apache Iceberg table, I create a new snapshot, and it's going to be through the catalog that the newest version of the metadata with that new snapshot gets tracked. So if that catalog doesn't know, then any other engine that wants to look at that data is not going to be aware of what the latest snapshot is. So we're going to use Nessie. So as you might remember, we have a Nessie catalog that's part of our Docker compose.yaml. So we're using that Nessie catalog. So basically here, the settings we have to pass to set up that Nessie catalog. Type Iceberg, because it's we're basically setting up an Iceberg catalog. Okay, we're going to use the Nessie catalog class because we're using a Nessie catalog so that we can get all those Git-like features. Okay. The IO implementation, that's going to be like sort of how we write things. So we're using an S3 compatible storage in Minio, so that's why we're going to use that. The URL to the catalog. Okay, so that's going to be the URL to the catalog. Okay, and then authentication, again by default, it's going to be none. Okay, and then here we have ref. Ref stands for branch. Okay, so essentially you can create branches, kind of like you can create branches in Git with Nessie. So theoretically, if I wanted to ingest all the streaming data into a branch before I publish it to main, okay, I could ETL it to a branch, run some quality checks, and then do a merge from that ETL branch into main to publish that data, kind of like a write, audit, publish pattern. Okay, the difference is just I'm writing it to a branch, okay, and then I audit it, and then I publish it through merging. So I like to say BAM, branch, audit, merge, but same idea. Okay, but here we're just going to use the main branch. We're not going to have previously created any branches or anything like that for this particular exercise. Okay, we're going to make sure that it knows which region we're assuming. US East 1. We're using that warehouse bucket that was created through those commands in our Docker file. And then this is going to be the URL to our container with Minio. Okay, now I find that I need to get the specific IP address for this particular line to work as intended. Okay, has something to do with just the way the network is set up within Docker. So what we're going to do is I'm going to go spin up Minio first. So I'm going to go say Docker. Well, actually, I'm going to keep that terminal as it is. Make a new terminal. Okay, I'm going to say Docker compose. Actually, we'll just do them all in one. Just basically, when I do Docker compose up, it's going to just generate everything. Okay, and we already see there's an error. Okay, so let's take a look at what this error here is. Error for storage cannot create container for service storage conflict. The container name storage is already being used by container. Okay, I think I have something else running still that I must have not taken down. So basically it is, let me just make sure that I take down everything. So Docker compose down. So that way I take down anything that currently might be running. And then I think I might have that name from the previous time I ran this job. So what I'm going to do is I'm also going to clean out all my containers. So I'm going to say like Docker container prune. And that should prune all my stopped containers. So that way I don't have any container with those names. Okay, because I've gone through this tutorial quite a few times now at this point. Okay, cool. So now that I've cleaned that out, let me go back to this terminal. And I'm going to say Docker compose app. And again, all that does is reads the Docker compose.yaml. It's going to create all those services. And because I did it in one terminal, the logging for all four of these services are going to be all in this terminal. So it's going to be a barrage of logs. But that's fine. We're not going to need them too much, or actually really at all for our purposes today. So it's fine if it's just a big continuous stream of logs, but you see it's actually generating 6 services. So you see it generated our catalog. That's our Nessie catalog. The 2 Flink containers, the task manager and the job manager, our Minio storage, the Minio client, and that Spark notebook. And you can see like there's the barrage of logs as all these containers start doing their thing. And you can tell which container is doing what because they're labeled. So you can see like Minio client say putting this out, the Spark Iceberg catalog is putting that out, and so forth. Okay, but that's it. So now technically my environment is running. So I have Nessie, I have Spark, Minio, all these things running currently. Okay. So what I'm going to do now that that's up, I need to get this IP address. Okay, I need to get this IP address. So I'm going to go back to this terminal, and I can get access to the innards of one of those containers by doing this here. I can say Docker compose exec, meaning I want to execute a command against that particular container. IT, meaning I want to go into interactive mode, so that way I can type commands in that container. And the container that I'm targeting is the service name storage in the Docker compose file. And I want to run the terminal, which is running the bin/bash file that's on there. Okay. And generally any Linux-based container should have /bin/bash. So I hit that, and that did not do what I wanted it to do. Did I make a typo somewhere? Docker compose. Oh, oops, I wrote Docker compose. That's why it's Docker exec. Okay, so Docker exec. Here we go. There we go. So see, now I'm in the container, so you can see my prompt change showing that I'm inside that particular container. And I just want to run the command ifconfig. This is going to put out all the network information for that particular container. And all I really care about is this value right here, the inet value. That's the IP address I want. So I'm going to just copy that right over. Okay, and that's essentially the IP address for the Minio container on this basically fictitious network that Docker is creating on my computer. Because what it does, it creates like a little mini virtual network with all these Docker containers sort of operating and talking to each other. Okay, awesome. So that's all set and good. Okay, so I've done what I need to do there. Okay, so look at the inet value. We've done all that. Good, 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 good. Okay, and we've updated that. Good. So technically our package should be good to go. So I'm going to go back to this first terminal, and I'm going to create the Maven package. So I got to make sure first I cd into the Flink job folder. The reason being is I got to be in the same folder as this pom.xml, because the pom.xml is what gives Maven all the instructions. And then from there I can run Maven package to then package, okay, that to package that Java jar. So if I run that, okay, it's going to basically run that. You know, if there's any issues, it'll pop up, but otherwise, hopefully everything runs fine. So far, looking good. Okay, compiling, 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 and good. Okay, so successful. And you'll see that if you go inside that Flink job folder, that now there's this new folder called target, and in there you can find the jar. So you see here Flink job snap jar, this jar file right here. Okay, and that's what we're going to need for Flink. So again, we did that Docker compose up earlier, so that means Flink is running. Okay, so if I go to, remembering the port off the top of my head, that's going to be localhost 8081. So again, localhost refers to your computer. All in that Docker compose file, we mapped ports on all those containers to our ports on our local host interface, meaning our computer. And 8081 is where we mapped Flink to. Okay, so here's Flink. There's Flink's dashboard. And all I want to do is click on Submit New Job. Okay, so I'm going to click on Submit New Job. That's going to take me over here, and I can then add a jar with a job that I'd like to run. Okay, so then I'm going to head over to where I have this stored. So I'm going to head over to testing, Lakehouse, Flink Iceberg, Flink job, target, Flink job 1.0 snapshot jar. Okay, so now I've uploaded the jar. Now, it's very possible that my jar may have many classes inside of it. So it's going to want me to specify, hey, what is the class that you want me to run? Okay, and you kind of have to put in the full path, including the package name. So it'd be like com.myFlink job. Okay, it's the package name. And again, if you don't remember what the package name is, it should be at the top of the file. See, com.myFlink job. And then saying, in that package, there is a class called app, and that's what I want you to run. And then again, if this were a more complicated thing, you might need to pass it some arguments and have some of these other details. But for us, we're just saying, hey, run that particular class, and we're good to go. So I hit submit. And if all goes well, I should get no errors. So let's hope for the best. If not, a little like thing of errors should show up. And again, any errors that any of these things show up should show up in the logs that you're going to see here. So if you need to do troubleshooting on what's happening in Flink, you should be able to see what's going on here in those logs for more visibility. Okay, but here's what I was talking about. Okay, so here the visual UI is showing you like those operators. Okay, so see, hey, look, that step of mapping worked. Okay, which we actually never went back and looked at, so we'll do that now. But the job ran successfully, and we'll confirm that the job ran successfully. But going back here, we created our catalog, we created our table environment. Okay, we went through all that. And essentially what I did here is we had to create, I ran a command called show catalogs. I just did that just to make sure it was working. And then printed the results so I could see it in the logs. That was just when I was first putting all this together. And then I'm saying, hey, let's use this catalog. So going forward, use the catalog we just created. Okay. Then here, we're going to create a database, okay, if it does not exist, okay? Because the idea is that we are going to create a namespace. So you have to create like a database, which in Nessie is really just a namespace, but it's got to be created before you can use it, okay? Nessie in its newer versions will no longer just create a namespace if it doesn't exist. You got to create it first. So in that case, we create that database just in case it doesn't exist. That's what this DB thing is. Okay, so we're creating DB. And now we can create a table in that database. Okay, so then I just run some SQL, standard create table statement. Okay, just creating a field with a data with two fields, a table with a unique ID string. That's our first Apache Iceberg operation. And now we're going to create some data to put into that table. So here we just create an arbitrary set of data. So basically what it is, it's 3 tuples representing 3 records. Okay, so it's basically a data stream object, which just means, hey, it's a data that we can stream into. And then it's made up of, basically here it's saying it's made up of tuples, and each tuple is made up of 1 long and 1 string. Well, we don't really care about data types right now. But essentially there we go. We have 3 tuples that match that data type, and we're good to go. But again, I wanted to have that one map operator. So right here what we're doing is we're taking that data stream and we're mapping it to the example data class. So instead of having a data stream of tuples, we're going to have a data stream of example datas in a sense. So that's essentially what this is doing. And again, this is what's creating like this one step here. Like that's the operator. This is the map operation is at this. So you can see like right there that the map job finished. All it's doing is just taking those 3 tuples, converting them from one data type to another. But then basically what we do is whether it's a data stream or whatever what we want to do is create it into a view. Okay, basically a SQL thing we can reference going forward. So that's so right here in our with our table environment, we say, hey, from this data stream, which is the map stream we just created using that map operator, basically create me a table that has these two fields. Okay, so basically you're going to create a table from that data stream, and then we're going to say, hey, from that, take that table object that we just created from the data stream and make it a SQL view called my data stream that we can now reference in our SQL. And then here, I just basically do an insert using that data. So I say, hey, insert to the table we created earlier, data from that view we just generated with that sample data. And that's going to insert our data. That's it. Again, this Flink job, what it can do is anything you want. Again, it could be processing Kafka streams or streams from AWS Kinesis, or it could just be, you know, hitting up a S3 bucket periodically and looking for any new files that are in there. Like where the data comes from could be anywhere. But the idea is like, how do I get into the Apache Iceberg table? Basically, the first thing you want to do is get it into that data stream, take that data stream, turn it into a table object, turn that table object into a view, and then you can just use SQL to do the insert. Or if you don't want to go through all those steps, you could just use Java or Python if you're using PyFlink to imperatively just take that data stream and inject it into Iceberg. Okay. Now, just to confirm that we did this, let's go head over to Minio. So you can see that like the storage got created. Minio, actually it's not there. It's a localhost 9000. It's going to take us over to Minio. And that's going to be, in this case, I think it's admin. And let me actually refer to our Docker Compose and what the password was for Minio. Minio password. So it's admin and password. So I hit login. Okay. And if I click here on warehouse, because again, in our catalog settings, if I go back to app, we said that the warehouse bucket is where data is going to be stored. See, we see the DB. Let me go back. So see, there's that namespace we created when we did the create database statement. So created this namespace to create tables in. And then there we see the table that we created, table 1. And inside there, we see the data for table 1 and the metadata for table 1. Okay, so we see that was all successful. I see Parquet files in there. I see JSON and Avro files over here. That's all good. Now, great, the actual data is created, but does the catalog know that the table was created? Because again, if I were to connect this to Dremio or Spark, they're not going to look at Minio. They're going to look at the catalog to know, hey, do these files exist? And then the catalog will point them over here to look at that data. So also in here, we show you how we can just do a quick API call. Okay, let's just go to where that part here is. Make a quick API call to this URL. Okay, so I'll just open up one of these, exit here because that's still inside that container. So I can just do a curl. Again, a curl is just basically making an API call. You could do this with Postman or Insomnia, whatever your favorite API call tool is. But I can do a curl, just hit that URL. So again, because I have Nessie running on port 19120. Okay, and then what this will do is just show you that, hey, like this is like data that the catalog currently has, like the most recent commit. And I can say, hey, look here, here's that commit where we created the database namespace. Okay, so you see like it created a database namespace. And then here is the commit where we created that Iceberg table. So you can see, hey, we created a table called table 1. Okay, and then at that point it says, hey, like the most recent snapshot is this metadata.json file pointing to that, you know, warehouse bucket. Okay, but then we made another transaction. Do I see both transactions there? Well, you see that there, oh yes, because that is the current. It's always going to just reflect the most current. So right here, it's saying, hey, the metadata location for that particular namespace, db.table1, is here. Okay, and basically anytime we change that table, that changes. Okay, that's going to point to a newer metadata.json file, and that's why every query engine always has consistent access to the data, because basically this catalog acts as the source of truth for what is the current metadata for the table. And it does that atomically. So hopefully you guys enjoyed that and give you a little bit more for appreciation for like Flink, Nessie, Apache Iceberg, and just working with streaming data into a data lakehouse a little bit more and thinking about how you might want to architect that. But again, read the blog, check out the other videos on this channel, so make sure to like and subscribe. And thank you guys very much. I'll see you all later around. Make sure to follow me on LinkedIn. I'm always putting out more content on the Lakehouse space.